Okay, we're going to do one more of those scientific notation things. So we have 81, which is 840,000 times 0.03 divided by 0.00021 times 600. So we need to convert all these to scientific notation. So 8.4, 1, 2, 3, 4, 5, 10 to the 5th times what number between 1 and 10 starts with a 3? Well, 3. So you get 3 times 10 to the 1, 2, so negative 2 power. Next, what number between 1 and 10 starts with a 2 and has the second digit of 1? 2.1. 10 to the 1, 2, 3, 4. So it's 10 to the minus 4. What number between 1 and 10 starts with a 6? 6. Start from here, 1, 2, 10 to the second power. Let's group all the constants. So you have 10 to the 5th times 10 to the negative 2 divided by 10 to the negative 4 times 10 to the second. Okay, let's do the numbers first. So let's see if we can just do some simplification. Well, we got 8.4 over 2.1. Notice 3/6 can become 1/2. Also, 8.4 divided by 2.1 is actually 4. So it's a factor, common factor is 2.1. So that becomes 4 times 1/2, which is 2. So all this stuff at the front becomes 2. And then we have 10 to some power. So we take 10 to the 5th plus 10 to, we're going to add the exponent. We subtract the exponents that are in the denominator. So you got 5 minus 2, which is 3. Here we have plus 4. So we got 3 plus 4 is 7. And then you subtract 2, which is 5. So you get 2 times 10 to the 5th power, which is 200,000. Because you have 2, and you have to add 5 more zeros to have enough space. Actually, in the old days, if it wasn't nice where you could simplify that, we'd use a slide rule to do these calculations, and that's where we get this number from. Okay, now we're moving to 84. So these are word problems. By area, the largest of the 50 states is Alaska with a land area of a big number, while the smallest state is Rhode Island, which is that number. The total area, land area of the United States is about, well, we're just supposed to rewrite these in scientific notation, so it's not really, it's kind of a bogus word problem, but so let's just rewrite these. So that is basically just, they're big numbers, so let's rewrite them. So what number between 1 and 10 starts with the 3, and it has these additional decimal values? And what we do is we go from here, which is where the decimal point is in the answer, and we count how many things we have to move to the right to get to the end. So we go 1, 2, 3, 4, 5, 6, 7, 8. So it's 3.65482 times 10 to the 8th power. 677,000, 6.77 times 10 to the 1, 2, 3, 4, 5. And then the last one is 2, 2, 7, 1, 3, 4, 3, 0, 0, 0. So we get 2.271343 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. And just for your 10 to the 6 is million, 10 to the 9th is billion, 10 to the 12th is trillion. Okay, next is 87. Multiply. All they want to do is convert 10 billion. So that's 10 billion. So that's going to be 1.0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the shorter version of 10 billion, which is a lot easier, especially if I dropped that 0 and it just said 1 times 10 to the 10th. Okay, 91. Solve each problem. In May of 2008, the population of the United States was 304.1 million. So there's two ways of thinking about this. A million is 10 to the 6, so you could write 304.1 million. So you can rewrite this as 3.041 times 10 to the 2nd power, because you put your decimal point here to get a number between 1 and 10, and you'd have to move it 2, you'd have to go to the right 2 to get to where the decimal point is. Then you write your second term, then you use properties of exponents to add the two exponents. So you add the two exponents, and you get 10 to the 8th. Or the other thing is you could just move this 2 units and then add 2 to the exponent and get the same thing. It's sort of the same operation, just in one step. Okay, what's the next one? Solar luminosity requires, oh, what am I, 91. Right, 1 trillion, that is 1, blah, blah, blah. We already talked about that, but 1 trillion. So that's a million, that's a billion, that's a trillion. So in scientific notation, it's going to be 1 times 10 to the 3, 6, 9, 12. So it's going to be 1 to the 10 to the 12. And the final thing says, using your answers from part A and B, calculate how much each person the year would have to contribute in order to make someone a trillionaire. So what you do is you would, this is a trillion, so how much would each person need to contribute? And I could write out along numbers, but we should use the scientific notation. So you basically take $1 trillion and you divide by the number of people, like that. So again, you can do the constants, and I forgot to write 10 there. So this, if you use the properties of exponents, you're going to have 10 to the 12th, and then you subtract the exponent in the denominator. So you get 1 over 3.041 times 10 to the 4th power. 12 minus 8 is 4. If you do the math there, 1 divided by 3.041 is 0.329 times 10 to the 4th. And if I move this 1 decimal point, then I have to reduce this by 1, because if I reread the first number, in scientific notation, which means this number has to be between 1 and 10, it's going to be 3.29. And I have to move one thing to the left, so it's going to be 10 to the minus 1 power. And then I multiply it by the second term. So when you add these exponents together, you will end up getting 3.24 times 10 to the third, which is $3,290 per person. Have to contribute. Okay, 94, we're going to finish all these up. The distance from Uranus, not Uranus, but from Uranus, from the Sun. A parsec, a unit of length used in astronomy, is 1.9 times 10 to the 13th. So parsec equals 1.9 times 10 to the 13th miles. The mean distance from Uranus from the Sun is, I'll just say D, is 1.8 times 10 to the 7th miles. How many parsecs is Uranus from the Sun? Well, this number is bigger than that, so it's going to be a fraction between 0 and 1. And what you would do is you take D divided by the value for the parsec. So you'd have 1.8 times 10 to the 7th miles. And if I divide both sides by miles, I'll get, or both sides by parsecs, I'll get 1.9 times 10 to the 13th miles per parsec. And what would happen is the units, these are going to cancel out, and the parsec will come to the numerator. So I'll get parsecs as the answer. But notice I've got this, and so what you end up with is you divide 1.8 divided by 1.9, and I'll get 0.947 times 10 to some number. Well, it's going to be 10 to the 7th minus 13, and this is going to be parsecs. So that's 0.947 times 10 to the minus 6 parsecs. Again, I'm going to want a number between 1 and 10 to get the right final units. So I'm going to move that to there. So 0.947 is 9.47 times 10 to the minus 1. Then multiply it by 10 to the minus 6. So the final answer is 9.47 times 10 to the minus 7th parsecs. So, you can see parsecs are used for more things like distances between between stars, and not between planets. If you remember that from Star Trek, they talked about parsecs, and there they were able to magically go between large distances because they had warp drive, which I don't know how that worked. Okay, a light year is the distance that light travels in 1 year. Find the number of miles in a light year if light travels at 1.86 times 10 to the 5th miles per second. So what we need to do is, what we're trying to do is figure out the number of miles per light year. So what you have to do is you have to figure out how many seconds per year. So you've got 1 year times 365 days times 24 hours per day times 60 minutes per hour times 60 seconds per minute. And so these will cancel out, and you'll end up actually per year. So let's cancel out. So we get 365 times 24 times 60 times 60. So 315,360. Okay, so that's seconds per year. And we can write that in scientific notation. It's going to be 3.1536. 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th seconds. So now all I have to do is multiply by this times that. So if you take 1.86 times 10 to the 5th miles per second times 3.1536 times 10 to the 7th seconds per year. We multiply these two numbers together, 1.86 times 3.1536. That's 5.8. We'll just round up to three numbers. 5.87 times 10 to the, well, 10 to the 5th times 10 to the 7th. You add the exponents, you get 10 to the 12th. So it's 10 to the 12 miles per year. And that should be the answer. Miles in a light year. 5.87 times 10 to the 12th.